Welcome to the Bachelor's and Master's of Science of Software Engineering program, breakouts. If you have questions as we go through this, just to let you know, please pop them in the chat. I'm supposed to have other people with me. They're not, but I'm okay. I can run this on my own. But I will probably have to scroll up to kind of see what people are saying or where they're at. Yeah, so feel free to ping as needed in there. Oh, it looks like Lisa just came in here. Let's see if I can get her invited to the stage. I'm not sure she's on stage. But anyway, we'll continue forward anyways. Let me start by introducing myself. I'm Jared Plum. I'm the Associate Dean and Director for Software Engineering. A little bit about my background. I've been at Western Governors for about getting close to 2.5 years over the software engineering program here the whole time. Before that, I ran a computer science and software engineering program at another university. And then before that, I was actually in the professional world. I was actually a programmer, so I'm not all academic. My background is in game development. So there's some interesting stories there, but I won't go into tons of it there. But yeah, so the one thing I'd like to discuss a little bit here, I think at the very beginning is that kind of when introducing myself is that I really feel that the beauty of software engineering is where we take this concept of theory and we apply it. And it's that application that's really the focal point. And I think that's kind of how I feel with my experience and with how we like to run the program is this notion of getting into that application oriented way of doing things. So let's talk about a little bit of what is software engineering. So a lot of you I know are going to be here, and probably one of the questions I'm going to see a couple times is, should I choose this or computer science? And that's kind of a complicated question, but we'll kind of talk about a little bit of the difference here and what we're doing. So software engineering is really about the full life cycle of building software. It goes from the planning stages to the where we create stuff, where we just get around and we don't where basically we get the whole cycle, including the programming itself. We focus on testing, we focus on verification, and get done. What's kind of different in computer science is computer science can cover all these topics, but it really kind of focuses a little bit more on the specific algorithm and application side of things. And so I think that's kind of really where software engineering differentiates, but also what is software engineering itself. And so these are a couple of diagrams somebody had given me, I think shortly after I had watched when we were having a conversation. I said, hey, here's what software engineering is. And they said, hey, this is a cool diagram that kind of shows that notion. Lost my mouse there for a second. Okay, so in the software engineering program, we have a bunch of skills here. So the common skills that you see, are basically a bit more soft skills, where you see things like communication, management, leadership, troubleshooting, problem solving, things you hear a lot. In the hard skills, you can see on here on the side that software engineering itself is a hard skill, but the software development, agile methodologies, programming languages such as Java, C#, Python, basically JavaScript, SQL, these are the hard skills. And a lot of these you will learn, depends on the track that you choose, but most of these are within the software engineering program itself. So why study software engineering? So I think, the big draw that a lot of people have to software engineering, you got to be careful with is the high salaries. There's a great salary right off the bat, in these programs, post these programs. The challenge is, though, is if you don't like a lot of that problem solving, then, and sitting down on a computer all day, then that's not necessarily the driving factor. The biggest thing I think is if you really like to solve those problems, if you like to be on these teams and be presented with something highly technical and say, hey, we can find how this system works and we can utilize that system to build something. That's really what software engineering is all about and what we end up doing at that point. Okay, so common job titles for software engineering. You can see here on this list, I won't go through all of them, but these are really common. Software engineering and software development are probably the two biggest. I like to joke around a little bit with that, and that is that ideally you want a software engineering job, not a software developer job, but both are fine. And the reason I usually say that is that companies that really understand what a software engineer is actually will have it as a software engineering position. Companies that don't quite always get it, a lot of times call them programmer positions. However, they are really interchangeable at the end of the day. And that's why you see going down this list, you'll see the word engineer, developer, and programmer kind of interchanged in the different titles that exist there. A lot of you are already familiar with the top companies that hire software engineers. What is interesting modernly is every company hires software engineers. It's no longer really limited. It's all over the place. And so I think that's something to kind of comment. That there are the top companies people think about, such as on here, Apple, Amazon, Google, Microsoft. But really, I think people don't always think about these other places that are hiring. You'll notice like, banks, JP Morgan Chase hires programmers, right? GE hires, it's Internet of Things is very common in those positions now. So it's pretty much everywhere that these positions exist. Okay, so something I like to discuss is software engineering right for me. These are a couple of questions I asked that this conversation had come up once, with a student, and these were kind of materialized after a while of it. So the question is like, what I like to mention is I don't really necessarily know if you're a programmer or not. The challenge here is that you have to kind of decide this on your own, and the best way to really decide that is to take a programming course. But I think after you take that first programming course, you do need to take a step back and say, is this really something I'm going to enjoy? You need to be able to succeed in this field, you need to be very adaptable, be able to learn new technologies quickly, be able to change. A lot of times you'll learn a programming language in college, and then you'll go to the industry, and that's not even the language they'll have you use. Maybe even right away you'll change. I had a student once who really liked C#, learned a ton of C#, and then the first position that student got was with Python, and they just said, "Hey, we're confident that you'll be able to be fine in Python." And so, basically the student ironically hadn't even coded in Python, and then they had to adapt to it. These things happen a lot. By trade, I was a C++ programmer. However, that shifts based off of where you're at, what you're doing. You need to be pretty adaptable. And so if this all sounds really fun, then software engineering probably is right for you. If that sounds terrifying, then software engineering might still be right for you, but it's kind of a situation where you kind of have to kind of self-realize and say, does this work or not? Okay, so let's talk about the Bachelor's of Science of Software Engineering first, the BS in Software Engineering. And then we'll get into the Bridge and the Master's in a minute for those of you who are looking for questions about that. So we built these degrees. We constantly utilize industry experts and even update the degrees from time to time, and always just saying, hey, what does the industry really need and want? This isn't a degree that's intended to go like, if you're looking to, become a professor, or go into heavy amounts of research, this isn't really a degree for those, unless it's professional research at software companies. It's really intended to get you into those jobs as an actual programmer. These are a couple of the key topics that we like to cover here. Basically, we have kind of a front end and a back end side, which we'll talk more about in a second here. But then you also see we even get up into some QA, and it's about that process and those set of courses. There are two tracks within the software engineering degree. There is a Java track, which is the default. If you don't switch, you're automatically just in the Java. However, within the first 6 terms, you can at some point decide that you would rather do the C# track, and then you can basically, you'll talk to your program mentor, and that they can swap you to the C# track. And so really the difference between the two is that in one of them, most of the courses are the same in both of them. However, there are just a few courses where one of them they do it in Java and one of them they do it in C#. You'll learn, I think, Java no matter what. You'll take a couple of Java courses. You'll learn JavaScript. You'll learn Python. You'll learn a lot of other languages. But in this back end portion of it, there's a shift from one to the other. We do offer two certificates along the way, a back-end developer and a front-end developer certificate that you'll get once you complete those courses. What's kind of fun about those is you do get those once you complete it. They'll email it to you, I believe, and so you'll get a nice little PDF that you can print out right away. But they're part of it further down. We also do have three certifications in this program that you can see here on the right. These certifications are the professional certifications, and the courses themselves are aligned to help prepare you for those certifications. And then you actually take those certifications to pass the course. So. Okay, so here's some examples of products and tools you'll learn in the Java track. The reason I like to say this is examples is because we are ever evolving and updating the courses. This is a field that changes quite frequently. And so this list could potentially change as we do it. Right now, we push very heavy with Git, and we use GitLab to help facilitate that. And a lot of the courses utilize that. We also have Docker, Spring. Currently, we use Angular. We do always debate going back and forth between Angular and React. And that's why I mentioned that these are kind of examples, because by the time you get to that Angular course, it could be a React course, it could be Angular. We kind of let the market decide how these courses shift. Okay, let's talk for a moment here about the what we call the Bridge program, or the Accelerated Bachelor's Degree. This program is designed for those of you who are getting a bachelor's degree and have the expectation that you will go on to get the master's degree in software engineering. It's designed to overlap. It's mostly the same degree, but it's designed to overlap a few of the courses, very specifically 4 courses, into the bachelor or into the master's degree itself. What happens when you go into the master's degree is you'll end up choosing a specialization at that point. But as you come into this program, basically you'll choose to say, I'm going to get the master's degree. You finish the bachelor's degree first. They don't wait to award it to you until you finish the master's. You get awarded it as soon as you finish it. But it does become a cost savings. Within the master's degree itself, there are 3 tracks to choose from: AI engineering, domain-driven design, and DevOps engineering. So a couple of other quick facts about this Bridge program. There is no C# track in the Bridge program. It's only Java. And part of that is because of the overlaps that we have created. We couldn't really facilitate it in there. Because of the Bridge, though, you do take a master's level cloud course instead. And so the AWS certification is not part of this degree either. However, you do still get the front end and back end certificates from us along that path. The advantages is that it does accelerate. You do take 4 master's courses over the course of the program, and you do potentially save money and time, assuming you keep that progress going correctly. The challenges are there is an increased difficulty because you will take master's level courses, and master's level courses are harder. And a lot of times they expect that you're going to jump ahead and can study on your own. And so the challenge also is the potential knowledge gap, as that can sometimes be a big step from the previous course upwards. So this kind of shows a general outline for those of you who were curious about the path to get there. Basically, what you have is these set of terms that you're doing that are just the normal software engineering courses, and then you'll do a few courses, and then you'll basically graduate with that bachelor's degree, and then you'll go on to the master's degree and take the courses as needed. You take the standard courses first, and then at the end of that program, you take the specialization. So let's talk about that master's degree a little bit more. So the average length to complete the master's degree is 18 months, basically a max time of about 24 months. So it's basically the standard master's 2-year program. This is the list of the core courses that are required in that master's program. We tried to create a program that hits the 4 pillars of software engineering, but does it kind of in a not directly by addressing those pillars, but making sure we cover it. So you'll notice that we do dive right into data structures, and from a programming standpoint, we do get into architecture and design in there. We do talk about basically what are some of the regulations and laws associated with this. And we do get into the QA aspect. So you see that we kind of have the life cycle in there. It's contained within courses like software engineering and QA. Actually, let me go back for a split second here. So then what happens is that you go into one of the specializations. The most popular specialization, as a lot of you are probably aware, is AI, anything AI oriented, but AI engineering is probably our most popular ones. The general career outlook for this is that the expectation is that you'd go into some sort of AI engineer or AI architect type of position. It could just be also, as the field is maturing, it could very much just help get into those senior type positions. If this is your first job, you're probably not going to dive into a senior position right away. That takes some time, but this just helps give you a huge leg up into where you'd be potentially going there. In the concentration, we're focusing on the application of AI. So it's not necessarily writing the machine learning level code. It's more like using the APIs of machine learning to be able to build software packages themselves. Domain-driven design, if people are looking for a simpler term, it's probably just computer architecture or software architecture, sorry, not computer architecture, software architecture. It's basically the role that this happens, that we're getting into, but we're focusing specifically on the elements that build into that software in regards to the components that it takes to build a piece of software. And so a lot of bigger, more complicated software projects are designed with specific pieces in mind, so that teams can interact and they can update as needed. Concepts of like microservices are really big modernly, where you build the program as lots of little programs that interact with each other. And these concepts are what is explored in this program. And then our last concentration, which is probably the most useful. I know AI engineering is more popular, but DevOps engineering is probably the more applicable topic for this field. DevOps engineering has become a very huge topic within the industry. It's really how do you orchestrate the continual development of software. If we go back in time, it used to be people would build software, release it, and be done with it. As a console game programmer, I understood that world, right? But the world is more complicated now, and the fact that people expect their software to keep running and keep updating. How do we do that? How do we develop a product that potentially gets out to customers early, quickly, and keep coding? How does QA fit into this process? These are the types of topics that are part of the DevOps engineering. Okay, and then for the master's degree, something kind of not kind of, really worth talking about is what does it take to get into those? A lot of you who are in here are in the bachelor's degree now, and you're probably wondering what it takes, especially if you already have a bachelor's degree in these programs. That's sometimes a conversation. So you can get into it by just having the appropriate bachelor's degree. If you already have a software engineering or computer science degree, data science, any of the degrees that would be a natural step in here. Those are easy step-ins. If you already have that bachelor's degree and you're kind of curious what it takes to get in there, once you've taken an object-oriented programming course, we actually will accept that as admission into the program also. I will say that it can be a big step, especially if the object-oriented programming course was a bit light on the object-oriented programming. Going straight into real-life applications data structures can be a large step. However, in the master's world, those steps are acceptable, and it's really up to you to study to get there. You can also, you'll notice in option 2, we do offer introduction to programming in Python as a stepping stone in there. One of the cool things about it is if you do go to Academy and take this course, we do credit that amount back into your tuition so that you don't have to pay extra. So anybody who's interested in that. You can, option 3, I did actually recently admit the first student using option 3. It's a complicated one, but if you do have 2 years of industry experience as a programmer, and you already have that bachelor's degree, all these require that you already have a bachelor's degree. But if you do have a bachelor's degree and you do have 2 years experience, you can get into the program. We just have to kind of vet that and make sure that that the skills are appropriate in that setup. Because a lot of times people as a programmer, the programmer roles aren't necessarily appropriate for the skill set you'd need to be able to get to the next step. But we have seen at least one student who did go through this path to get there. And then there's a number of certifications that you can have gotten. If you have one of these, as seen in this option 4, that also can step you into the program. That's also, it's a fine path. The object-oriented programming course is usually the easier path in those cases, but some people do have those. Other certifications can also be considered if you do have ones that are very programming oriented. But this was the list when we had created this program that we made to this list, I guess. Okay, so questions. I'll start scrolling through the chat here. I do see Lisa on. I don't know if you can talk. I don't know if anybody can hear you or not on stage or anything, but I can hear you. Yeah, but I don't think anybody else can. There's a way to bring you onto stage, but I don't know. It doesn't. It seems to be grayed out. So, but yeah, you're welcome to also chat, Lisa, the answers to some of the people who have questions on here. So. Okay, let me go back here. Let's see. Okay, yeah. So Eddie's question here about can I switch? The answer is yes. Talk to your mentor. If you are already down that path, there's always personal reasons of like why you would switch. The mentors can help with those conversations. But yes, if you are already in the bachelor's degree and you're interested in the accelerated program, you can swap to the accelerated program, especially if you're early in the program. You'll lose no progress at all. There is a challenge if you're at the very end of the program. Let's say you only have one term left and then you decide you're going to switch. Those accelerated courses haven't been taken yet. And so you would potentially have to take additional courses. And so usually it's better to graduate at that point and then just go into the master's degree. But for those of you who are in it, who are interested, you're more than welcome to switch over. Yeah, okay. I was wondering if AI questions would come. Okay, so to answer Jared's question, great first name too. But to answer Jared's question here, yes. It's interesting. A lot of people have read, like, hey, AI is going to replace programmers or anything. And I always just keep answering that's people who don't know what programming is. It does hallucinate it a lot. I keep trying to use AI to build code, and it is interesting. It can do simple tasks very easy. It just can't do the complicated things. And so I think what's interesting too is when it gets held up. I was doing a crypto. I was doing a crypto algorithm once, trying it with ChatGPT once, and what was funny is it named a variable hash and a function hash, and it kept just erroring, could not figure out for the life of it. It went down a rabbit hole it couldn't get itself out of, where a real programmer would not, first of all, do that. And if we did do that, we would just go back and change the code and understand moving forward. But since it kept kind of trying to grab that chat history, it had issues. And so I encourage people to use these tools. Your jobs are going to require it. The world is changing, right? And the expectation to use these AI tools is very, very important. It's also very important to still understand the foundational pieces, because when things break, how do you know when they break? And so I think that's something really important to note. We are incorporating AI where we can into the courses, and there's a huge push to try to get what I call AI-assisted programming in place. I think that vibe programming is probably not going to really exist within a software engineering program. Maybe early on you could do a little vibe programming, but I think that but the AI assisted programming, I think that's very much a powerful thing that's going to happen. Um, and then also, yes, I agree. Engineer is usually the topic, the title people are looking. Programmer is used a lot too. When I was at Microsoft, I was a software engineer. When I was at Disney, I was a software programmer. And so it just kind of depends on the company and depends on what they end up using. So for the C# comment here, I think it's Drina. I think the yes, if you're in the C# track, you can still go in the master's degree. There's not a bridge for it, but you just graduate and then you just go into the master's program. And so if you're already in that, especially if you're really far into that program, it still leads into it. I mean, technically, if you're in the computer science program, you can go in the software engineering program. So there's many paths into the master's degrees. And finishing the bachelor's degree will satisfy those prereqs and you'll be fine. So, uh, and yes, I do hear a few of you said I can't hear the second person. Yeah, I'm not sure why, but she's there. She's smiling. She looks great. You just don't get to see it, I guess. Yeah, Tor, that is an interesting question I've never seen. What's a good time of year to start the program for working professionals? I will say not the maybe not in December when everybody's taking time off and you need to, go see your family and everything like that. It can be, I guess, depending how you're doing it. But the first 45 days of a program are really important that you really get some time to really dedicate to learn how do you do courses at WGU, how do you succeed on the courses, and really to finish a course. If you can finish the first course in 45 days, it's great. And so I would say that when the best time for working professionals probably depends on what your professional life is like and what you're doing. But right, for instance, September is a great time because everybody goes back to school in September, so they get that it's a good time to start, right? But you got to realize that there's going to be times at which you're going to want just a little bit of a break. Like, I'll see a student, for instance, who will go through a program. They'll accelerate and they'll take a bunch of good courses, and then they'll hit a month and they'll just realize, hey, I'm going to just take the rest of the month off, right? Yes, for us, we like it if you keep working and chugging along, but at the same time, it's really what works for you, what helps you succeed, and having those breathers can be important. Yes, Seda, I think that is a very good question that maybe I didn't make clear. You don't have to get the master's and the bachelor's together. They're very separate programs that you do not have to even link at all. And so even in the bridge, when you take the bridge program, you finish the bachelor's degree first, and then you go and take the master's degree. And so we would prefer you don't drop out, but at the same time, you can drop with a bachelor's degree at that point and then come back and do the master's later. And so they're separate programs at the end of the day. Okay, Bryce, you asked the question, the big question: what's better, C# or Java? I think actually you said Java or C#. Um, So this is complicated, I will say, in any world. I like to talk about the rings around Microsoft. If you live in Seattle area, I would say C# is better. As you go away from Microsoft, it becomes more and more Java. There are a lot more Java intro programming positions than there are C# ones, but there are a lot of C# ones. Especially in fields like medical and stuff, you'll see medical devices for whatever reason use a lot of C#. Like the software they build for the offices and stuff seem to be in C#. But that's also just kind of coincidence. That can change. Tomorrow, Microsoft could make an announcement that suddenly, some new AI thing has been released under C#, and suddenly C# becomes the bigger language. The languages change over time. So in actuality, I would say personally, I probably like C# better, but I've always had a hard time finding use for it outside of Java or C++ for me. But it just depends what you like. I think that the biggest thing to remember is that you're going to learn these languages, and about 80% of the languages are the same. Defining a class in Java is very similar to defining a class in C#, even to the point where some of this code you can copy paste between the two languages and they still work. But I think the thing also is to not get held up on the language. You're learning the language to basically learn how to code. I would say in some ways learning both is good, learning numerous languages, and then really just kind of figuring out how to build stuff, showing a future employer, look, I can build stuff in this language. You may or may not ever be in that language, but it kind of is up to you. But I would say overall in a worldwide market, Java is probably better. But like I said, if you're in Seattle, C# is probably better. So. Okay, let's see. Yeah. So also say that in your job market comments, this is an interesting one. I get this question probably every open house. The market's not in a good state, which is interesting that every open house has this. And not just open houses here, but for 5 years before I was here, I was in another school. And this was also the question there. Um, the is market news is pessimistic about where the markets are always at. The market does go up and down a lot. The beauty of being a strong programmer is that you end up being able to jump between jobs as needed. And it is kind of part of this field. Most programmers have been through a layoff. Most have been laid off. A lot have survived a layoff too, right? This happens. But the market is that the market as a whole may look pessimistic, but also it's always doing better. You just have to look at the right areas. The beauty is that as the markets sink, they come back up, and then sometimes they come up really strong. So in 2008, we saw market crashes, right? And jobs were horrible. But by 2010, salaries were significantly increased from what they were pre 2008. And so, and then we saw this again, I think it was like 2018 or something. We saw another crash. Then we saw the COVID crash, right? We see these crashes happen, but the markets usually rebound really heavy. And a lot of it has to do with technology shifts. As people are starting, like right now, there's an AI push, right? There's a lot of, hey, we can replace programmers. Once they realize that those programmers aren't easily replaced, and the market readjusts, you see the hiring happen. So yeah, so it's kind of part of the field, and it's good that you've been watching that. But I think it's also try to read between the lines. News is pessimistic. Try to look and see what the truths are within that news. Uh, so Jarena, I would say that meet with a program mentor, maybe to ask that in more detail, because it might be more specific of what you're doing, or an admissions counselor. Both of them can potentially help. I think that might be the easier way to say it, is see if your specific case is applicable. I'm out of time. Let me see if there's just one last. Last question I do want to clarify for Jonathan there at the end. Yes, we do use the .NET Core and the .NET Foundations, I think, frameworks. And so those are the C# is about building applications in it. So great question. I am out of time. I want to thank everybody for your questions and for being here. And I hope to see everybody around as needed and really see you at graduations. So thank you.